Good afternoon. Welcome back to the acids and bases. We have seen the Arrhenius theory and the Brownsville-Lowry theory. Now Lewis theory is a more advanced for the acids and bases. Acid is a species which accepts electron pair. Accepts electron pair is acid. Donates electron pair base. Simple example is the boron trifluoride and ammonia. Here ammonia gives the donates the electron pair. So lone pair whatever it is under it donates. So as per the theory, donates means base. Not necessary that any H or OH is required in the aqueous solution solely and all. It boron trifluoride, boron is accepting the electron there, so it is acid. Similarly, some more examples. So if you see OH minus, it donates, so it is a base. Fluoride, it accepts the H plus or donates the electron, so it is a base. H plus acid. BCl3 anyway BF3 or BCl3 and all this like this one. Now that is the Lewis basis. As per this latest we can all categorize all the acids and bases. Now comes to the ionization. Ionization means when it is added in the water, it will split into the cations and anions. That is the ionization. More so, perchloric acid. Perchloric acid is one of the strongest acid. Strong and weak. However, if it is completely dissociates in the water, that is strong. Or completely ionized also. Some people say dissociate, some people say ionization. Both are same. So strong. HClO4, H2SO4, HCl, HNO3 or NaOH, all these things are very strong. KOH, whatever it is, they are all very strong. So because they ionize more, their ionization is very nice. So now already we have seen the acids and bases and the ionization. One which is the lower ionization. So if it is the strong acid or strong base, the corresponding conjugative acid or base will be a weak. Suppose HCl is a strong acid, means HCl's conjugative base is a weak base. Similarly, NaOH is a strong base, its conjugative acid is a weak acid. Okay, that is the conjugative, and sometimes question may be asked. Not. Then comes to the scale of pH for the normally for representing the acid base. What is this pH? This is hydrogen ion concentration, potential of hydrogen. Then, so how it has come and all these things. H2O is a liquid which sometimes acts as acid, sometimes acts as a base, dissociates into as ions itself as H plus, some people say even H3O plus, H3O plus, but normally H plus or H3O one and the same, OH minus. How much it dissociates? The dissociation depends on temperature. Remember very carefully and please listen carefully. It is a temperature dependent. H2O it dissociates at particular temperature, normally 298 Kelvin, that is 25 degrees centigrade. Dissociates into H plus and OH minus. So as usual we write the K equilibrium Kc, here it will write Kw, that is the equilibrium constant of the water, equal to, what is that, H plus or H3O plus concentration into OH minus ions concentration by H2O, because H2O we are told that H2O will be normally taken as 1 because it is a very high concentration and it is a liquid, so this will be omitted. So Kw is nothing but H2O into OH minus. Practically, when measured at 298 Kelvin, H3O plus concentration is 10 to the power of minus 7 moles, 1 into 10 power minus. Similarly, OH also 1 into 10 power minus 7 moles at 298. That means Kw equal to 1 into 1, 10 to the power of minus 14 moles square by H2O this thing. So, this is mole square at particular temperature. Pure water is density equal to 1 at again same temperature and molar mass is 18. So, how many moles of the in 1 liter? It is 55.55 moles. That means the Kw will be around 10 to the power of minus 9 and all these things. Now, coming to the Kw is H minus H plus and all. So, pH was defined as negative logarithm to the base 10 of the activity of hydrogen ion or activity of hydrogen ion concentration. pH defined as minus log base 10 and hydrogen ion concentration. H plus concentration. Some people say activity AH plus also, some people say no. Remember, here is the most important thing. pH will be measured only if it is a lesser than 0.0 or at least 0.1 molar concentrations only, either H or OH. For higher concentrations, pure liquids of HCl, NaOH and all these things, pH will not be measured. Typically, all MSETs and all the NIT questions papers and IIT will ask the what is the pH of a 36% HCl concentration pH. So, will not measure, there will be so many answers, but the pH will be measured for only the concentration if it is less than, normally less than 0.1, sometimes some books write say the 0.01 also, but pure liquids the pH will not be measured. Similarly, NaOH or sulfuric acid or any acids and strong acids, because they are beyond 0 to 14. So, this is the for the lower concentrations, this is for the regular water solutions only it is applicable. Very limited application, but wide, very range this thing and all, very critical applications. So, now from this, normally the pure water is the we have already seen, this is a pure water. Pure water is a, because of the less number of ions, it is non-conductive, means very less electrical conductivity, pure. Okay. Then, this much is only dissociation time. It is a temperature dependent. So, now, if pH is less than 7, acidic. If it is equal to 7, neutral. If it is more than 7, basic. Range is 0 to 14. From where it has come? Because this H into OH minus equal to 10 to the power 14, and so the range is given as 14. 0 to 14 at 298 degree Kelvin only. 298 Kelvin only. Very important. Okay. Then, so what will happen to the, if I am increasing the temperature? This is also one of the IIT question or bar questions and all these things. What happens to 0 to 14 scale of the pH if the temperature is increased other than the 298? If it is increased or decreased? If it is increased, the scale will get condensed. 12, 13, 14 depends upon the temperature, because the dissociation is more. Dissociation is more with respect to temperature. When the dissociation is more, number of ions is more. Number of ions is more, the range will be the less. Other way, if the temperature is lesser, closer to the minus 15, like that, it is coming to the 5, 6 degrees of the centigrade, then the range will be more. So, it is a temperature dependent, but normally measured at the 298 Kelvin. 298 Kelvin. Okay, but the neutrality will not change. Again, remember, neutrality will not change. The scale only is going to change. Very important. Scale will only change. Neutrality will not change. So we will see some more interesting these things in the pH. Okay. Thank you.